Hello everyone, I am Indrajyoti Gaine and I am presently a PhD scholar at Department of Mathematics and Statistics at IIT Kanpur, and I am pursuing my PhD from here, and I am a PMRF fellow, and I have cleared CSR NET with 108 rank. Okay, so in the last class we have discussed about formula of cardinality of union of two set. So recall the formula first. The formula was like this, where if A be a set, if A be a set, and N denotes the number of elements, N equals to the number of elements in the set. This notation stands for the cardinality of the set. Okay, so yes, this is the cardinality of this set. Then the formula was then we had n of A union B is equals to n of A plus n of B minus n of A intersection B. And we have done some few examples in the last class. So today we will start with another example of this formula, and that is let's write the question first. In a survey of 400 students in a school, 400 students in a school, hundred took apple, 150 took orange, 150 took orange, and 75 people took, 75 students, 75 students took both. Okay, then the question is how many students were taking neither apple nor orange. Okay, the question is how many students were taking neither apple nor orange. Okay, so the thing is the question is like okay, let's draw the example so that we can clearly understand what the requirement of this question. Okay, this is the universal set which is cardinality 400. That is the number of students in a school. That is the universal set, or you can say the universal set is the school number of, the students of the school is the universal set, and 100 took apple, right? So let us draw it by okay, apple, okay, orange, and it's like this. This is set A, and this one is set O. This one is set O. O for orange, A for apple, and the common section is this. The common section is this. So they have given that the red section contains 150 students, the yellow section or the orange section contains 100, and the white section contains 75. 75. Now the question is, how many students are taking neither apple nor orange? So we need to find this portion, this blue portion. We need to find this portion. Why this portion? Because these are the students who didn't took apple or orange. The students in the red portions took at least one apple. The student in the yellow portion took at least one orange. The student in the white portion took orange and apple both. But if a student lies in the blue portion, then he or she didn't take an apple or an orange. Okay, so we need to find the blue portion. And how can I found this blue portion? So find the blue portion or the number of students outside this union. We need to find how many students in the blue portion. So the students number is cardinality of U minus cardinality of A union O. Why? Because just see, I am drawing with green line. This is the total student. This green portion is the number of total student who took either at least one fruit. Okay, that is the area between the green portion is the collection of all students who took at least one fruit. So rest students didn't take at least one fruit. That is, they didn't take any fruit. So the cardinality will be this. Okay. Now how can I calculate this? So for that we need to calculate this first. So what is this and what is this? This is 400 and we don't know about this. So we need to calculate this one. Okay, so calculate this one. What is the formula? N of A plus N of O minus A division O, which is equals to, okay, I have written something wrong here. This is not 75, it is 100. It was 100. Right? Okay. So what about N of A? N of A is 150, N of O is 100, and N of A resistance O is 75. Okay. So this thing is 250 minus 75, that is 175. So what about this? Then we can clearly write N of U minus N of A union O. This is equals to 400 minus 175. This is equals to 225. This is so 225 students were taking, these students were taking neither apple nor orange. Neither apple nor A in G. So we have solved this problem with the help of the formula of cardinality. Okay, so by this process we can found many of the questions of the set theory. Okay, let us do another example with the same formula, and then we will go with the formula with union of three set. So this example is telling us that there are 200 individuals with a skin disorder. Okay, there are 200 200 people with skin disorder. Okay, and among them 120 had been exposed to the chemical exposed to the chemical C1, 50 to chemical C2, and 30 to both C1 and C2. Then find the number of people um, who exposed to who exposed to chemical C1 but not C2. Okay, so the question is little different from the previous one, because in that case they asked for the number of students who didn't took neither apple nor orange, but in this example they are asking for the number of people who are exposed to chemical chemical C1 but not chemical C2. So here the operation is not with the universal set, because we are not finding the complement of some union. So let us draw the Venn diagram, then it will be a little bit clear what is the requirement of this question. Okay, so there are 200 people with skin disorder. So therefore this is our universal set which has cardinality 200 people. Okay, now few people are exposed to C1, so this red one is C1, call it by C1, and this blue one is C2. Now this blue set contains 50 people. This red contains 120 people, and the middle portion, that is white portion, this contains 30, right? Yes, 30. This contains 30. Wait, it is not that much clear. Yeah. 30. Okay. Now what they are asking for? They are asking for people who exposed to chemical C1, that is inside this red one, but not in C2. But not in C2 means those elements which are in C1 but not in C2. So by definition, they are asking, okay, after that we will go. They are asking this set. What about this set? Yes. What about this set? Now, based on our previous knowledge, what is this set? This set is nothing but, this yellow one is nothing but C1 minus C2. Okay? This set is nothing but C1 minus C2. Or one can say this thing can be, which is equals to, it is set equals to C1 minus, this set is equals to C1 minus C1 intersection C2. Okay, why this is? Because whenever we subtract C2 from C1, then we are eliminating only those elements of C1 which are common in C2. So it doesn't matter we exclude C2 or we subtract C2 or we subtract C1 intersection C2, because in both the cases the result will be same. Okay, yes, but this is the correct notation. But for our basic understanding, or for our uh, helpless, for our little convenience, we can write this statement. Okay, now this becomes little easy. Now if you understand this statement, then this statement, this answer will become little easy. Why? Because we just need to find number of C1 minus number of C1 intersection C2. Okay, because clearly C1 intersection C2 is subset of C1. So if we eliminate only those elements from C1, then we are left with the number of students who are exposed to chemical C1 but never exposed to chemical C2. Now what is this answer? This answer will be 120 minus 30, which is equals to 90. So 90 students, 90 people got exposed to the chemical C1 but not in C2. Okay, so I am not writing the answer here again. You can write it. So let us go with the formula of N of A union B union C. Okay, so before that, let us draw the Venn diagram first, and then it will be clear to go with these things. This is our A, this green is our B, and the blue is our C. So obviously, what is A union B union C? The whole white part. This is A union B union C. Okay. Okay. So now we need to find what about N of A union B union C. Okay. So first of all, we know the previous formula. We know this formula, right? So here we will use this formula to find the formula for A union B union C. So let us consider this as D. Then this is nothing but N of A union D, and this thing will give us N of A plus N of D minus N of A intersection D. Okay, so this is, if I clearly write it, then it will be like similar: N of A plus N of B union C minus N of A intersection B union C. Okay, now if I explicitly write it, it is equals to N of A. I am writing this as a explicit formula. So what will be this thing? This thing will be N of B plus N of C minus N of B intersection C. And what is this thing? This thing will be equals to N of A intersection B union A intersection C. So this is equals to N of A plus N of B plus N of C minus N of B intersection C minus, we will use the formula. So what will be this? So let us write in the bracket A intersection B plus n of A intersection C minus n of A intersection B intersection A intersection C. Now what is this? This is nothing but here we have two intersection of 2 times A. So this thing is nothing but A intersection B intersection C. Now write it again and we will get the answer. This is equals to n of A plus n of B plus n of C minus n of B intersection C minus n of A intersection B minus n of A intersection C plus n of A intersection B intersection C. And in general, we can extend this number of union to n many elements, and that thing will work like this. So if I write it like A union, okay, not like that. Let us take some notation to denote it. Union of I runs from 1 to n AI. Then this thing is write in different color. Then it will be very much clear. Cardinality of I runs from 1 to n AI. This notation is denoting for okay, let's write it explicitly first. So if I denote it as A1 union A2 union A3 up to AN, then what will be this? Cardinality of A1 union A2 n. This is equals to at first n of A1 up to n of AN minus n of A1 intersection A2 minus n of A1 intersection n, and so on. All we will take all the pairwise intersection of A1 up to AN, and we will subtract all the cardinalities. Then we will add n of A1 intersection A2 intersection A3, and all these three kind of combinations. I mean combination of all three elements, and we took the intersection and we will add all these numbers and so on, and we will repeat this process up to per n cardinality of A1 intersection A2 intersection n. So if you put it formula here, so if you put n equals to 3 or n equals to 2 in this formula, you can clearly deduce the formulas for n of A union B union C and n of A union B. Okay, so in case of 3 elements or n equals to 3, we went up to n of A intersection B intersection C. But when we had only 2 elements n equals to 2, then we went up to A intersection B. Okay, so thus we can find up to nth many terms, and this is called the inclusion exclusion principle. Okay, so this is the formula for A intersection B intersection C. Now do one small example of using this formula. So the question is, a college awarded 38 medals in football, 15 in basketball, 20 in cricket. Okay, so college awarded 38 medals to football, 15 in basketball, and 20 in cricket. Okay, now if these medals went to total of 58 men and only 3 men, not like men spelling is very bad, only 3 men got medals in all 3 sports, in all 3 sports. Then how many received medals in exactly 2 of these 3 sports? Two of the three sports. Okay, so this is the question. So what is the question again? Understand with the Venn diagram. So you don't need to worry about the Venn diagram and understand the questions in Venn diagram in the exam hall or in the competitive exam time, because right now we are learning, so we need to be clarify about the question and what is the demand of the question. But whenever you are in a competitive exam and you have lack of time, then it is enough to understand the question and you can proceed with the rest of the thing. You don't need to draw the Venn diagram and don't need to explain everything to the uh, in the exam hall. It is for your convenience. Don't need to bother about the answers in to include this Venn diagram in the answer. If they're asking for the Venn diagram, then obviously you could include that Venn diagram. But if they don't ask for the Venn diagram, then don't include this Venn diagram. So okay, I'm drawing the Venn diagram again. So football means F. Okay, this is the white one. This stands for F, football. This yellow is the basketball. So this stands for the B, and the blue one is the cricket. This stands for the C. And due to the question, the number of white is 38. Number of C is 20. And number of yellow is 15. And they have common one thing, they have already given that 3 men. So the whole portion is not like I will write in red. This portion is 3. This portion has 3 elements. Okay. This portion has 3 elements. And the total number of elements given is here. Total set equals to 58. Okay, so write all the necessary important statements. So in of cardinality of F union B union C, this is equals to 58. N of F intersection B intersection C, this is equals to 3. N of F equals to 38. N of B equals to 15. n of b equals to 15 and n of c equals to 20. Okay, so what I need to find? I need to find in geometrically we need to find. Okay, geometrically we need to find. Let us take a different color so that we can understand it properly. Okay, this color will be good. Okay, we need to find this portion. So mainly this portion we need to find. So we need to find about n of f intersection b plus f intersection c plus n of b intersection c. What is this number? So use the formula. So we have all the information here. So we will use the formula. What is the formula? The formula is telling that n of b f union b union c. This is equals to n of f plus n of b plus n of c minus n of b intersection c minus n of f intersection b plus this thing will be there minus intersection fb fbc fc plus n of f intersection b intersection c. Okay, so put the numbers from the above. 58 equals to 38 plus 15 plus 20 minus this number enough. Okay, denoted by purple color, so we can use the purple color to choose this. Say this number is m. Okay, so minus m, so minus m plus what is this number? This number is 3. So what about this minus m? This m equals to this m equals to this m equals to what? It will be equals to 38 plus 15 plus 20 plus 3 minus 58. So this is nothing but 18. This is nothing but 18. Why 18? Because this clearly see 38 plus 20 minus 58. So this term will cut. So we are left with 15 plus 3. So this is equals to 18. So thus we have found exactly how many sports person or people got exactly 2 sports. I mean 2 medals. The number is 18. Okay, so thus using the formula of cardinality, we can find many problems and we can solve these real life examples like this. And if you don't understand the question, then please draw the Venn diagram so that answer becomes too clear, or what the requirement, you can understand what is the requirement. If you are clear about the requirement of the question, then it will be very much easy to answer the question. Okay, so let us see some more examples of set theory, sets except these things, and we have done about the Indian integration parts. We have done about the okay, sorry, what's happened? Okay, so we have done all the union and integration parts from the different previous classes. Now let us see some examples about those things which are from competitive exams. So at first the question is, can anyone say that if A intersection B equals to A intersection C, then B equals to C holds or not? Let us check. Let A equals to 1, 2, 3. B equals to 3. And C equals to 3, 4. Okay. Then clearly you can see A intersection B equals to 3 and A intersection C equals to again 3, but B not equals to C. Okay. Now question is, if A union B is equals to A union C, then B equals to C holds? The answer is again no. Why? Take the previous example, or no, not a previous example. So manipulate the previous example. Let us take A equals to 1, 2, 3, 4. B equals to 3. C equals to 3, 4. Then what about A union B? 1, 2, 3, 4. And what about A union C? Again 1, 2, 3, 4. So if these two are sets are same, but you can clearly see that B and C are not equal. Okay. Now the question is, if A union B equals to A union C and A intersection B equals to A intersection C holds together, then B equals to C holds or not? The answer is yes. In this case, no. In this case, no. The answer is yes. How? Let's see. We have YOLO. We have this one and this one. So let us use these two things. First, A union B equal to A union C. And again write it here, so it will be easy to digest the problem. Okay. So take intersection with B here. So take like this. You will see intersection B. So we can clearly do it because we are nothing. We are, if I call the set D, then we can say this D intersection B equals to D intersection B, right? Because these two sets are equal, so we can write like this. So this thing will imply A intersection B union B intersection B, our distribution law. And what about this? A intersection B union C intersection B. Okay. Now, what about A intersection B and union B intersection B? So this is nothing but B. Or we don't need to be bothered about this thing. We don't need to be bothered about this thing. It is enough to say B, because B is a subset of A union B, and if I take intersection, then obviously we will get B. So if I rewrite this line again, it will be like B equals to A intersection B union B intersection C. Okay. Okay. Now In similar way, we can take intersection with C. C. Now, what will be this? A intersection C union B intersection C. And what is this side? This is C. And the previous logic. Now we have this thing. So using that, we can write A intersection C equals to A intersection B union B intersection C, which is equals to C. Now check, this and this are equal. Hence, together we can say B equals to C. So, by this proof, we can claim that if A union B equals to A union C and A intersection B equals to A intersection C holds together, then only B and C will be equal. Otherwise, they will not be equal. Okay. Now, see another question. The question is, for three sets A, B, and C, if A equals to B intersection C and B equals to A intersection C, then which option is correct? A subset of B, A is superset of B. This notation denotes for superset. This is nothing but B subset of A. Okay, so this is nothing but the notational change. So we can write it like B subset of A equals to B, and fourth one is A subset of B complement. Okay, so this thing we can write it like A superset of B. So how can I understand which set is included in which set? Okay, so whenever we can write it like A subset of B or B is superset of A, these both are same. Okay, and how can I understand that which set is lies inside which set, or which set is subset of which set? So under this gap, this we can say under this gap, which set is under this gap, that set is bigger. So this is our notation for set. So which are here, these are big. Which are here, that is small. Okay, so keep in mind this thing. So it will be easy to understand which set is lying inside which set, so that you can easily calculate all the other things. We'll keep it here, no problem. Just change the color. Can I change? Yes, I can change the color. Okay. This is the question. Now, given question is A equals to B intersection C and B equals to A intersection C. Now, if I draw the Venn diagram, if you not understanding, then let us draw the Venn diagram. So it will be clear. So the given set is like B and C. So let us draw B by blue and C by yellow. Then what is A? A equals to B intersection C. So this is our A. Okay. And the next statement is saying that this is our C, and this white is on or A. This white is in or A. Then they are saying that A intersection B equals to C. That is A intersection C equals to B. That is, this set is again B. Strange, na? Something strange. So it will be easy to use those things like A equals to B intersection C, right? A equals to B intersection C. So obviously this is subset of C because B intersection C is a subset of C, and which is equals to A, then A is subset of C. A is subset of C. Now we have this statement, right? So write it. Now we have B equals to A intersection C. Now since A subset of C, we can clearly write this is equals to A. So whole together we obtain B equals to A. So whole together we obtain B and A are equal. So this option is correct. This option is correct. Okay. So let us see the another example of set theory. Okay. Question. Let xn equals to x plus iy. That is not like that. Okay, we need to worry about complex numbers. So let us skip this question right now. We are not aware of complex numbers, so okay. The question is, for two set A and B, for two set A and B, find A minus B. The options are B, A minus B, A intersection B, A complement, not like complement, A prime intersection B prime, and this is learning for complement. Okay, so how can it be answered? So in this case, you can do it by the set operations, or else it will be very much easy if you do with the help of Venn diagram. Okay, so let us do with the set operation first, then we will see which one is easy. So let us divide it, and which is the answer. The both most important is the finding the correct answer, not in correct in short form. Obviously short process is necessary, but in the basic level, in the first glance, you need to do it correctly. You need to answer it correctly. Okay, so what about this set A minus B? Okay, so we know the fact, right, that A minus B equals to A intersection B complement. We have done this thing in the last class. Okay, so we will use that fact. So A minus B is equals to A minus A intersection B prime. This is equals to A intersection B prime whole prime. This is equals to A intersection A prime union B. Okay, this is equals to, here we have already used the De Morgan's law. So check it, how we get obtain these two lines. Check. Okay, so now we will use distribution law. What is A intersection A prime union A intersection B? So this set is 5 because both are complement. A intersection B, which equals to A into this one. Now do it with the help of Venn diagram. This is the set U. This blue one is our A. This yellow one is our B. Okay. Now what they are asking for? A. Now A is blue. What about A minus B? Okay, draw it. A minus B is the green portion. This green portion is A minus B. Right? We have discussed this thing. Then if I subtract A minus B, this green portion is A minus B. Now if I eliminate those elements which are in A minus B from A, so what are the rest of the elements for A? That is obviously this portion, right? This is the portion which are we left with, right? So what is the set? This set is A intersection B. So clearly by just drawing the Venn diagram, we don't need to worry about all these calculations. We can easily see the answer is A intersection B, and there are many cases where you need to understand, is it easy to proceed with the way of Venn diagram, or you just do the calculation to achieve your answer. Okay, so it is completely come with your practice. With regular practice, it will be clear in your mind that is it easy to use the Venn diagram, or it will be easy to use the formulas for the given question. Okay, so thus we have found the answer of this question is A intersection B. So A minus B equals to A intersection B. Okay, so we are left with only one example, and that we can't understand right now because we haven't done the set theoretical approach, or we can do a different way. So we all know about this R2, right? R2 plane where we have point x comma y. Now we are denoting an xn. We are denoting an xn, which is the collection of all those xy, such that x square plus y square is less than or equals to 1 by n. Okay, or by n square. It will be easy. Okay. So the thing is, if this is the case, then what is the set? The set is like, if I draw a circle of radius 1 by n, radius is 1 by n, then this xn is the green portion. This is the green portion. Okay. Now I am reducing this n like this. If I increase the n to 1, 2, 3, 4, and so on, then the 1 by n will get smaller, and we will get a smaller circle. We will get smaller circle like this, and so on. Now the question is, what about intersection of xn? N runs from 1 to infinity. Is it a finite set, or is it a singleton set, or is it a empty set? Which is this set? Like, it can be an empty set, it can be a singleton set, it cannot be a finite set, it can happen that it is an infinite set. So what is this? Or it is a finite set with more than one element. So clearly, if you geometrically see this example, then obviously you can see, if I take the intersection, then we will left with very few subsets. Like, if I take the intersection, then which is the smaller circle, or you can say which is the smaller disk, we will left with only that set. Okay, so if we do if we do the integration of all these extents and we will run this n up to infinity, then we will only left with 0. Why? So let's just try to understand the fact. See, this is our 1 by n radius, ball of radius 1 by n. Okay, and just suppose that this is our another disk with smaller radius. Okay, see, if I take the intersection, then we will left with only this set. Why? Because this red disk is subset of this white disk, and if I take the intersection, then the smaller set will come out. Okay, so now we are doing the infinitely many extents intersection. So ultimately, it will get smaller, again smaller, and so on, and it will come up with only one point, that is 0, 0, 0. This is not singleton 0. This is a singleton set in R2, so this will be like this. Okay, so the answer is this set is a singleton set. Okay, so please try to understand this example. This is very interesting example, and just by geometrical understanding one can easily do this problem in just one line, or but just by drawing the figure one can understand, or one can solve this question. It is very easy, and just try to understand the concept of this problem. Okay, so let us stop here.